Hello, this is Jack Jackson. In this playlist, we're going to be looking at some applications of integration. This is a continuation of our Unit 7, where we introduced some applications of integration there. In this playlist, we're going to be looking at volumes by slicing with elementary shaped slices, volumes of solids of revolutions by the washer and the shell methods, arc length, surface area of revolution, and then some physics type applications, work, moments, centers of mass and centroids, fluid pressure, and fluid force. And then, of course, we'll do some review problems like we always do. First of all, one of the main reasons calculus quickly became perennially extremely popular is because of its applicability to modeling practical situations and solving problems in a wide variety of fields. There are many applications of the use of antiderivatives and definite integrals in mathematics, statistics, physical and biological sciences, social sciences, business, medicine, and many other fields. We will touch only on a few of these applications of integrals in these notes. We have seen that integration is the study of accumulation. One of the most basic interpretations of a definite integral is as the net signed area between the graph of a function and an interval of the x-axis. This accumulation of area is the default interpretation of integration. However, as we saw in the various applications in the Unit 7 notes, many physical phenomena behave like accumulating areas. We can use a two-dimensional graph of a real valued function of a real variable to represent a wide variety of things. Although the x values of the function are just signed horizontal distances from the origin on the graph, and y values are just signed vertical distances from the origin, they may represent nearly anything in the real world. Similarly, the product of these horizontal and vertical distances on the graph produces an area on the graph, but in reality this could represent many things. Therefore, integration can be used to solve many varied real-world problems. So recall that our Unit 8 notes on techniques of integration were a direct continuation of the Calculus 1 Unit 5 notes on antiderivatives and integration. And together they formed the notes for Unit 1 in Calculus 2. Similarly, these Unit 8 notes are a direct continuation of the notes from Calculus 1 Unit 7 on applications of integration. Together, these notes from Unit 7 with these notes from Unit 9 will be the notes for Unit 2 in Calculus 2. First, study or restudy the applications from the Unit 7 notes and, of course, the accompanying playlist in YouTube, and then proceed to the additional applications of integrals given in these notes. Now just recall that in Unit 7 notes, we examined applications of antiderivatives and definite integrals to the following fields and problem types: basic interpretations of definite integrals and antiderivatives. And then we looked at areas: net area between a curve and the x-axis, the total area between the curve and the x-axis, symmetry and integration, and how integration relates to curves with certain symmetry. Then we talked about the total area between two curves, and then estimating the area of an irregular shape. Then we looked at applying these ideas to motion, net and total distance traveled. We looked at the relationship among the position, velocity, and acceleration functions, making use of derivatives and antiderivatives depending on which one we started with. We looked at the average value of a function. We had some economics applications we looked at: revenue, cost, profit, marginal cost, marginal revenue, marginal profit, total present and future value of a continuous income stream, and the supply, demand, producer surplus, plus, and consumer surplus. These economic applications are typically covered in a survey of calculus class or business calculus class, and I make sure that I cover them in my Calculus 1 class as well. Then we also looked at probability, lots of good applications of probability, and when we take a probability function and we go from a discrete situation to a continuous situation, then we're looking at calculus. And we're talking about integrals to find areas which represent probabilities if we're looking at integrating the PDF curve. So we looked at continuous distributions, at the PDF and CDF. Some of the things that we did were finding probability, and then also mean, variance, and standard deviation of a probability distribution. And specifically, we looked a little bit about the normal probability distribution. Okay, so that's kind of what we did back in the Unit 7 notes. It's very useful to be able to visualize mathematics in a dynamic environment. The free program GeoGebra, you can get to it at www.geogebra.org, provides the environment for building many activities that allow us to explore a wide variety of mathematical ideas and applications. It's really nice because not only is the software free, folks like me who make applications with this also make those free for people as well. So from their site, you can access a wide variety of really cool applications for all kinds of math classes and other applications of mathematics to various other fields. And so I've created many of activities for calculus and have collected them along with some of the best activities I could find available from other mathematics educators in a GeoGebra book, which you can access via this link. And this one stop will give you access to numerous activities for exploring calculus. And I will also give direct links to the individual activities as they are used in these notes. So let's just start by going here very quickly. And let me see if it's going to go to that link. Let's try again. Oh, here it is. It's coming up. Okay, so here we see the the book here, and I have menus here based on the units or chapters of the way that we're going through the course. So the first 7 here are Calculus 1, and then we repeat a couple of those along with this new stuff for Calculus 2. And so, for example, right now we would be in this more integral part, and you can see a bunch of applications here. Most of these were created by, maybe all of these were created by other folks here, whereas I created more of them up here, say here, and up here. Okay, so you can go to this directly and use a lot of these things right away. So, for example, I'm going to use this first one here in my second video in this course here, or in this playlist here. Okay, so you have that access to that right there. Stop. At this point, before proceeding, go back and study or restudy the notes from Calculus 1, Unit 7, Applications of Integration. Work all the homework set 2.1 in WebAssign. Even if you took my Calculus 1 class and studied there, going back to review that and working this homework is probably going to keep you busy for, oh, I'd say at least a week or close to it. So please do that now, and we'll come back in our next video and start looking at some of these different things, different ways of applying integrals beyond or in addition to the ways that we looked at it in Calculus 1.